Okay, so we're going to pick up where we left off, and we're going to continue on with points, lines, and planes. Now, really, it's just lines, but, you know, it's a more interesting title. So we've looked at, I'm just going to get this in here so we've got it all, the vector form. Right, and there's kind of 3 different vector forms, but in the grand scheme, it looks like all the points on the line look like x naught, y naught, plus t times d1, d2. And so that's the vector form. And then we get into the parametric form. And the parametric form is x equals, oh, my cat's going crazy, x naught plus t d1, 1, and y equals y naught plus t d2. And that's where t is a member of the reals. That's not it. There is another form called symmetric. I don't think it has 2 M's, whatever. The symmetric form. And so the symmetric form looks a little bit different. So I'm going to leave some space here to kind of write the generalized form, but it's easiest to see where the symmetric form comes from with an example. So I'm going to grab an example. So imagine that we had, so let's start with the vector form. So example. Again, so if we had xy is equal to 7, 5 plus t times 3 negative 2, where t is a member of the reals, right? So there is the vector form. The parametric form falls out really easily. We know that, hopefully. X equals 7 plus 3t, and y equals 5 minus 2t. Easy peasy. So, you know, that's the vector form. I should label them, I guess. This is vector form. This is parametric form. Now, what we're going to do is we're going to get the symmetric form. What I want you to do for each of these examples, and again, t is a member of the reals here, I talked about the idea that t in any single point has to be a consistent t. So that means for any given point, this t has to be the same as this t. So what I'm going to do is I'm going to solve for t in each of these equations. So from the first equation, we're going to have x minus 7 over 3 is equal to t, right? I just move that over, divide both sides by 3. So that's from the x equation. And then from the y equation, we're going to have y minus 5 over negative 2 is equal to t. Well, what's cool is that this t is equal to this t, which of course means that this and this must match. So it's going to be x minus 7 over 3 is equal to y minus 5 over negative 2. And this is the symmetric form. Let's look with 1m, symmetric. And that doesn't look any better. I'm going to put 2 in. You know, you can make fun of me when I got it wrong. Okay, so that's the symmetric form, right? So if we think about generalizing, if we go up to here and we think about it, if I solved for t in this one, we would have x minus x naught over d1 equals y minus y naught over d2. And that is the general symmetric form. And what's cool is that the denominators, right? And I mean, I don't think you probably need me to point it out, but I'm going to point it out anyway. The denominators here, well, that's a bad color. These form the direction vector, right? So the direction vector can be seen in the denominators. So the direction is in the denominator. And then, you know, this, not with the negative, I guess this and this form your anchor point, or really your anchor vector, but your anchor point. Okay, and there it is. Okay, I didn't really give myself enough room. There is a third form, but it's a third form. I'm going to try and get that same color. It's a form that you've played with before. There is the Cartesian form as well. And the Cartesian form, well, it's ax plus by plus c equals 0. We didn't call it the Cartesian form when we were in grade 9. We called it the standard form of a line, but the Cartesian form of the equation is, in fact, another form of a line. And so we can take and we can solve for the Cartesian form by clearing the denominators down here. So if I want to get the Cartesian form, what we can do is we can cross multiply, right? So we're going to get negative 2x plus 14 is equal to 3y minus 15. And then get everything over on one side. So I'm going to have negative 2x minus 3y plus 29 equals 0. And you kind of say, haha, there it is. Well, you know what? It's not really. Cartesian form, again, has a characteristic that what we need to do is we need to have a positive leading coefficient. So I'm going to multiply through by negative 1 all the way. So we're going to get that's 2x plus 3y minus 29 equals 0. And there it is in the Cartesian form. Now, again, good form is to reduce this because really, if we thought about, you don't need to write this down, but if we had 4x plus 6y minus 58 equals 0, those are the exact same, right? Exact same line. Not exact same because they have different coefficients, but it's the exact same line. And so what we should do is we should always, first off, these should always be the coefficients, or all the numerics should always be integer values, right? So if you end up with a fraction here, you should clear the denominator out. Integer, positive leading, and in lowest terms is what we want from a Cartesian equation. Okay, so not that bad. None of this is all that bad. Again, it's just mechanical, and we have to be careful. So let's spend a bit of time here, kind of converting between forms. So we'll start with a very very straight up one. So example here. How about if we had start with an easy one? Y equals 4x plus 3. I would like for you to convert that to all the other forms. So if I need to enumerate them for you, there is the vector form. There is the parametric form. There is the symmetric form. And there is the Cartesian form. Right? So pause it, give it a whirl, come on back. Welcome back. So I'm not going to change how I do things. I am going to sketch this just because it makes my life easier. I've got a y-intercept up here at 3. It's got a rise of 4 and a run of 1, right? And so there's my line. Let's pretend it actually goes through that. Oh, I can't slide that in this one. Hang on. Do it down here. Whatever. Still pretend it's there. So it goes over 1 and up 4. Over 1 and up 4. So there's the form. We knew how to do that in grade 9 and grade 10 and grade 11 and grade 12. Now I want the vector form. So I'm going to say x comma y is equal to, I need an anchor point. Would always personally use 0, 3, but just to make it interesting, how about we use 1, 7, right? It would be the same regardless. 1, 7 plus, and now I need t times some direction vector. Well, what is the direction vector going to be here, right? So I'm going to just draw it on. So I have a direction vector, and it's got to be x comma y. So the x is 1 and the y is 4, right? So over 1, up 4. So 1 comma 4, and there it is. So there is the vector form of that line in 2 space. Okay, parametric form, easy, easy, easy. X is equal to 1 plus 1t, or just t, I think I'll put the 1 in there just because it's nice to be able to see the direction vector kind of sitting there. And then y is equal to 7 plus 4t. And for all of these things, we've got t a member of the reals, right? Has to be a member of the real number system. So there is the parametric form. Symmetric form is when we solve for t and set them equal to each other. So the x version of t is going to be x minus 1. And I'm going to put it over 1, again, just so that we can see the direction vector kind of hanging out there, is equal to y minus 7 over 4. And there it is. There is the symmetric form. And then the Cartesian form, I'm going to do it like this, I guess. I'm going to say, all right, it's going to cross multiply. So we're going to get 4x minus 4 is equal to y minus 7. I'm going to move that over. So we're going to get 4x minus y plus 3 equals 0. And there is the Cartesian form. So we've got vector form. We've got parametric form, we've got symmetric form, and we've got Cartesian form. Now, hopefully you could have just looked up. I made a mistake. Where did I make a mistake? Negative 4. Negative 7. Positive 3. I made a mistake somewhere. Did I? No, I didn't. Okay, we're good. I could have just rearranged this equation to get the Cartesian form, right? I could have lobbed the y over, and it would have been 0 equals 4x minus y plus 3, which is what I have, right? So getting the Cartesian form is dead easy if you've got the, y equals mx plus b form from grade 9. Nevertheless, there's how we go through the different forms, okay? Lovely. All good, okay? That's great. Thanks, guys. Have a lovely remainder of the week.